Hello everyone, today we're going to talk about centroids of composite planes and we will be working through a problem together. So a centroid of an area A, if you guys remember, is given by this general integral formula. And we'll be working through this problem here. Locate the centroid of the plane area shown. Centroids of common shapes, just a revision, these are helpful shapes to know the centroids of. This will aid you in solving this problem. So the problem, we're going to jump right in. Locate the centroid of the plane area shown. Solution. Divide the shape into three shapes. We see a rectangle, a quarter circle, another quarter circle. Draw the approximate location of the centroid for each shape. For the rectangle, it's approximately in the middle. For the semicircle, it's over here. No, for the quarter circle. And find the x and y coordinates for the centroid for each shape. So first for shape 1, the rectangle, we have that the distance in the x direction is negative 30 millimeters. For the y direction, it is 60 millimeters. And note that this is the same as the radius of the quarter circle. That's how we got the 60 millimeters. Next, we'll be jumping into shape 2, the quarter circular area. For the x coordinate, we have to use this formula for r over 3 pi. So for shape 2, we have that the distance in the x direction is equal to 4 times 60 millimeters over 3 pi, which is equal to negative 25.4648. For the y direction, we have that y is the same value, which is simply 25.4648, as you can see in the table above as well. For shape 3, the green area, the green quarter circular area, we have that y is equal to 4r over 3 pi. However, we have to do some manipulation because the orientation of the quarter circular area is different than the diagram provided in the formula provided right on top. So this distance will correspond to 25.4648, which is the same as the distance, this distance over here. So those will be the same distance. However, what we want is not that distance. What we want is the distance in the y direction over here, which is equal to 120 minus 25.4648, which is equal to 94.5352. So we have that. And in the x direction, we simply have the same as before, 25.4648. And those are all the information we need. So now for the solution. We will be summing up the moments about the y-axis, which is equal to the centroid of the overall shape times the three areas, the areas of the three shapes, the area of the rectangle minus the area of the first quarter circular area plus the area of the second of the third area, which is a quarter circular area as well. Why do we subtract? Well, because if you recall, the red circular area is the area we subtracted. Next, we plug in the respective values for each of the small shapes, the centroids of the x-coordinate of the centroids of each of the small shapes. We have negative 30 times the area of the rectangle minus 25.4648 times the area of the first quarter circular area. Why do we have a minus sign here? Because we have to subtract that moment because it's negative area, plus 25.4648 times the area of the third shape. So we get, after dividing both sides by the areas of the three shapes, we get that the x-coordinate of the centroid is negative 10 millimeters. So that is our answer. Similarly, for to obtain the centroid, the y-coordinate of the centroid, we sum the moments about the x-axis, adding the three areas together and then equating it to the y-centroids times each of the shapes area. And then after solving that, we will get that the value of the y-centroid is equal to 87.12 millimeters. So that is our final answer. As I said earlier, note the signs here, they're negative. So why is that the case? If we look at the problem statement, it's because this area over here is negative. So the centroid of that area will have to be subtracted. Thank you guys so much for watching this video. I hope this problem walkthrough helped you in your statics endeavors. And I'll be posting more videos.